Hi everyone, welcome back from the break. We're going into a bonus lecture now. Bonus means unassessed. It means that if you don't turn up or you never watch it or you fall asleep, it'll never have any impact in your life in relation to COMP1531. Okay, so that's kind of where it's at. What today is it's a chance to start to get your head around what web technologies are generally. What it isn't is it's not an opportunity to probably learn an extensive amount that would help you modify the front end for your iteration 3. That being said, I don't think that's a big problem because it's due in like 5 days or something. So this is really just kind of a taster to get your head in gear about what's actually happening on the internet. You're probably not going to learn much in this like relatively short lecture that will help you build that many things. It's more just, again, understanding what's going on. So in terms of understanding front-end design more, we don't really cover building, I should say, web-based front-ends in 1531. And if you think of like, what is a front-end? A front-end is something that people interact with, right? You have lots of ways of building front-ends. You can go and build web-based front-ends in web browsers. You can go and build native application front-ends with languages like Swift, Java, for mobiles. Like the actual, some of your mobile apps just use different languages. They're not web-based. They're just mobile-based front-ends. And then you have other types of front-ends like stuff you'll see like Google Chrome itself. Google Chrome, I don't know what Google Chrome is built in, but it's not built in web stuff and it's not built in mobile stuff. It's built in something else. I'm not sure what they build the GUI in, per se. Be something like C++, right? So there's all these different kinds of front ends. They're just things you interact with. What we're talking about today, though, is web-based front ends. In terms of getting more experience with these things, the kind of courses that go into more depth around these topics are, in terms of UX and design, there's like COMP1511 and 4511. They really dig into the, not the coding aspect as much as, what is a good interface? What do we want in one? Like, how do we kind of construct one? It's the kind of course that a non-programmer, well, there's some programming in these courses, but it's a kind of course that like a non-programmer could meaningfully take a lot away from. And then you have COMP6080, which is on the other end of the spectrum. It doesn't spend a lot of time thinking about how to build good interfaces. It's very much on the hard skill set of just how to actually make it happen. And in a lot of ways, today is essentially like a very light single-digit percentage taster of what you would experience more in a technical-based course. Though, if you're interested in some of this stuff, I think that's super critical. And in some ways, I don't know what the quality of these courses is, but in some ways, I would consider this to be more valuable, theoretically at least. And the idea is that, you're trying to not build crappy front ends. And in fact, if you want to go and have a play around with this website here, there's a website that kind of shows you like what the absolute worst case is of a front end. If you can navigate through the site, then good on you. So getting into it, to understand what a web-based front end is or a web-based application, you kind of first need to understand that there's this natural split, particularly in web in particular, between a front end and a back end, or what we sometimes call a client and a server. Now you probably already have an intuitive understanding of this either before this course or through this course because you've been building a server-side application the entire course, and you've also probably started to, well, I hope you have, played around with the front end. And you can kind of make sense of it pretty quickly, right? You have a server over here, or a series of servers, where your back end runs, and over here you have a whole bunch of different people's computers that are all running this code on the front end. And sometimes sometimes a back end's made up of multiple servers, but you've got your client side, your server side, and these things here are all kind of, interacting like that. I don't really like the terms front end and back end very much personally. I think client side, server side is a much better way of understanding things because, like, what is a back end? You can have things that look like back ends on a front end, hidden away in the layers. But the best way to think about it is you've got server side code that runs off-site, not on someone's device, typically for security reasons, for performance reasons, for interactions with the data layer, and you've got your client-side work, which we refer to as front ends, which is actually what runs on people's devices. Now that's really important because We'll talk about that in a sec. That's really important because of understanding how these kinds of front-endy client-side things run. The main kind of key languages we're going to very lightly touch on today are JavaScript, HTML, and CSS. These are like kind of the languages of the web, if you will. And a lot of it's very different to programs you've written so far. HTML and CSS in particular are quite simple, though they're going to be very different from stuff you've seen. JavaScript is somewhat like Python. It has some very stark differences, which we won't be covering today, but it's somewhat similar, just kind of conceptually. So we're going to write a very basic web application today. That's the key thing. Before we get into that, we're going to ask a really important question. What is a web browser? This is, I think, at the very beginning of understanding this topic, because I mentioned before that HTML, CSS, and JavaScript are all languages that are designed for client-side web stuff. And the way to think about this is that web browsers are essentially compilers on your computer, right? So like when you go to google.com, you have two things happening. You have code that's running on a Google server, and you have code that's running on your web browser. The code on the Google server has been compiled or interpreted on Google systems, and the code running on your web browser has been compiled and interpreted on your computer. So if you think about a web browser like a Python 3 interpreter or GCC, you can start to kind of put these languages in context, because it's all just code that you've written that your browser is interpreting and then turning into instructions to make things happen. I don't know where this sentence was going, but I'm sure I had an idea of it when I was writing this. So all of these like languages, HTML, CSS, and JavaScript, a lot of these are propped up by the web industry, or some of the companies that benefit the most from the web, right? So like Google's a great example. Google's invested a lot of time and money into JavaScript generally, and some of its capabilities. And HTML and CSS are all these are like kind of, international languages, like many languages that have these big committees, and people on these committees work at a bunch of different big companies, and everyone spends money on it for this kind of very indirect reasons that are made up of like, why would a company spend their employees' time working on new versions of JavaScript? Two main reasons. One's philanthropy. Big tech companies think they need to give back to the community in some way, so that's a big reason. They're like, yep, well, let's devote 0.5% of our budget to helping advance the cause of technology. Second reason big companies might do this, I think I said two, maybe there's three. Other reasons is not because big companies want to do it, but because employees actually want to do it. So like you find it again, some of the bigger companies, the types of people who are really interested in just volunteering, like they sit down on a Saturday and Sunday because they're interested in joining a committee meeting about the new JavaScript 12.8 standard, they tend to just work at these bigger companies too. So that's just what they do in their spare time, and there's certainly some correlation there. And then a third thing is that some of these companies really benefit from advancing this. A really good example. Google, generally, from what I've been told from people who've worked there, and some talks I've been to from people who used to be in like executive stuff, they love the idea of you being on the web, right? They want you on a web browser, because if you're on a web browser, you're likely to Google stuff. There's this kind of natural tension between Apple, who invented like the App Store, and web browsers, because I can't remember all the specific terminologies here, but it's like when you're in a search-based environment, Google's always winning. Whereas if you're on your phone and you've got a weather app, and you've got a this app, and you've got a that app, and a train app, you don't need to Google anything anymore. You don't need to use a web browser, right? So that means companies like Google can potentially lose out in that environment, because they have less people using the kind of ecosystem that they benefit from, where they can put ads in there. So this is a somewhat theoretical example. So companies like Google are interested in investing in better technology on the web, so that you're more likely to be in a web browser, right? That's like one of the big reasons. That's why everyone invests in things that aren't, substantially money making, because it all ties into a bigger picture. So that's how these things keep getting propped forward. And in a lot of ways, the last 10 years in client-side web development, we've seen some massive advances in terms of capabilities. Some absolutely massive advances, because it's kind of so well funded. Like, think about this, right? And I know a bunch of you are young, and I think many of you are probably... How much younger would you be than me? I don't know. think most of you are probably going to be 8 or 9 years younger than me, right? So it's like, you probably remember enough when you were a kid. It's like, there were things you didn't used to be able to do on the internet, right? Like the idea of Netflix, just having all these videos that you could stream all the time at like high bandwidth. A lot of games now are built directly, on the internet. Like think about you used to download more programs is the short answer here, right? If you wanted to convert a file from A to B, or you wanted to do something, you would often download a program. And nowadays you can do everything through the web browser. And there's reasons for that, because it's cool tech. Anyway, getting into these 3 kinds of key languages that are made up on the web, that the web's largely made up of. We have HTML, CSS, and JavaScript. We're going to start with HTML, and HTML stands for Hypertext Markup Language. Hypertext is, this is like a 25-year-old term when people, the internet was cool, so everything was like hyper, I guess. Doesn't really mean anything that fancy. And markup language is important, because what a markup language is it's like JSON. It's not a programming language. It's like a descriptive syntax. You can't program with a markup language, and I don't have a good markup versus programming. You can Google this and have a look at some things, and they'll give you some examples, like what's the difference between a markup language and a programming language. Here you go. Markups are mainly to do with annotating, interpreted by the browser. I don't think that's strictly true, because you can have markup languages that aren't interpreted by the browser. Oh, this is a bit crap. Anyway, you get the point. It's like, well, you don't get the point because I just gave you a bad example. But a programming language tends to have things like the ability to be compiled. It tends to have the ability to do loops and branching or something else. And a markup language is just stating facts, basically. Markdown, right? In GitLab, your readme.md, your other thing, assumptions.md, these are all markup languages. I know it's called Markdown, but these are markup languages because they're not programming languages. They're just declarative, like fact-based. Here is how it is, header, this, that. HTML is like that. And what I've got up here is I've got an empty file up here. And what I've done is I've created a file on my computer. There it is. It's in my Ubuntu WSL area. /home/hayden/dev/page.html. And what I can do is I can add some text here. Hello. Now the cool thing about HTML is it's interpreted by the browser. The browser is your compiler. You don't need to download anything to run HTML. You've already downloaded it. This is Microsoft Edge, but like whatever it is, Google Chrome. If I refresh this page, it's like what's happening here. Hello, Hayden. Save my file. The browser is the compiler and the interpreter. And it can show that. What HTML is HTML is a series of tags, we call them, where you typically, the structure of an HTML tag looks like this. You have an open tag and a closed tag. Many of you will have seen this before just by virtue of the fact that you're computer scientists who just, are a bit curious about some things. I would say CSS probably also counts as some kind of markup. I don't know formally what it is, but I would call it that because it's like just a declarative, non-Turing complete language, I guess. I don't know. So we have like an HTML tag like this. Now, it's the side brackets, the name of the tag, and then something happens, and then you finish off the tag, right? So / means end of tag, and you can put stuff in here, right? And what tends to happen is that whatever's between these two tags has some kind of property applied to it that's inherent to that tag itself. So an example would be, if I have a web page here that says, hello Hayden, how are you? I could put this one in an H1 tag, which is referring to a top level header, the first class of headers. There's like different header, like H1, H2, and H1 means the biggest header that exists. And if I put something here, such as a P, which means a paragraph of text, and I go and load this page up, you'll see that it looks different. So what's actually happening here is that we are specifying that this piece of content exists within this kind of bucket of styles, right? And this piece of content here exists in this bucket of styles. Now, think of this like your output. This is like your compiled output. But if you right-click on a page and you go to view page source, you'll actually see the source code, right? So again, it's a lot like normal programming. You have your Python file that's your source code, and then it might output something. So same thing here. Here's the source code. This is what the browser gets. The browser compiles and interprets that into this page, because a browser is a rendering engine, right? Like, it's not just about doing logic, it's about actually displaying stuff. So there's lots and lots of tags in HTML, right? We've got like different header tags all the way down to, you know, H6, right? It's like there's all the different header tags. They all have different kind of properties. We've got a paragraph there. You can do bold, you can do italics, you can do underline, right? And, you know, you can Google these. I don't need to step you through them all. You've got an unordered list. An unordered list is essentially dot points, right? And in an unordered list, you have list items. Item 1, you have item 2, item 3, and you can actually start to see here that we can nest particular things. So like there are my 3 items here that are described because they're inside of my unordered list, and you can actually start to nest these items. For instance, maybe I don't just want like bold, italics, and underline. What if I want to have these in bold? What if I want to have bold and italics like this, or I want to have bold and underline? So you can actually start to nest and combine these together like this. Or you could have, you know, bold, underline, and italics. The brackets do need to the tags do need to match up, of course. I think browsers are relatively smart. They'll figure it out sometimes if you don't do it, but that's ugly and confusing. So, you know, it's very hierarchical. You know, you could actually break this up and maybe make it a bit cleaner, have it look like this if you wanted to, right? Like, and that's the thing. Web pages are essentially hierarchies of layers. That's what happens. And there's tons and tons of different tags. You've got things like hyperlinks. If I want to link to, oh, well, actually, I'll get to that in a sec. So these are all your different tags, and there are lots of things you can do with them. What I have kind of glossed over here is that every tag has a series of attributes that you can apply. Well, not every tag. Most tags have a series of attributes that you can apply to them. I'll give you an example of a more complicated tag. We can create a table in HTML. I want to create a 2x2 table. And how a table works is you have a table tag, then you have a table row. So you're going to specify the rows that exist in that table. So this means 2 table rows. So I've got my 1 table, I've got 2 rows, and then inside each of those rows I'm going to have a, I don't actually know what TD stands for. What does TD stand for? Table, I don't think in all my years I've never figured this out. Data, table data, is that what it means? Yeah, data, sure, why not? I'm happy enough with that. Table data, and then I'll say 1 here, and then I'll say 2 here, and then I'll do the same thing here. I can just copy and paste it, so you can kind of again start to see the structure already. So now when I go and load this up on my page, you'll see I've actually got this little table here. Now it doesn't look like a table because it doesn't have lines, right? But so to recap, what we've seen so far is that you can have a page that has a series of HTML tags. Each tag has a set of properties that are applied to whatever inside of it, and you can nest these tags inside of each other. You could take this entire you could take this entire list here and you could put it inside your table. You could say, yep, this one here is actually going to have, you know, a list here like this. Now, it looks like crap at the moment, but it's actually a table, right? You've got like a quadrant over here, a quadrant over here. Now, one thing I've glossed over is that some HTML tags have attributes. Now, what attributes are a series of key value pairs that exist within the opening tag. For instance, a table tag can have a border property with a particular value. So think of this like a dictionary. And when I add that property in and I load this back up, there's actually a border that has been added here, and you can see the table a bit clearer now. There are other attributes you can add, such as cell padding. Cell padding specifies how much space you have between the contents and the borders. If a cell padding is 5, I think it puts about 5 pixels of space between your contents and the border. So this is HTML in a nutshell. It's just this. It's a tag that often closes, not always, with attributes that have attribute value pairs. So well, that's it really. A couple of other things that kind of matter. You might have noticed that HTML is not, it doesn't care about white space. So you'll actually see here that like my bold and my italics were not on new lines, even though I put new lines here. If I want to add a new line into my code, I can do it with a BR. BR means line break. And you'll see that this does that. It moves it down to the next line. And you might be thinking, what is this? Well, there are some HTML tags that, because there's nothing you'd put inside of them, they don't need to have a closing tag. It's what we call a void tag. It's something where like it opens and closes at the same time. Other examples of void tags are horizontal lines. Horizontal lines don't, like, what would you put inside of this? Like, what are you going to have inside of that? Like, what? That doesn't make sense. Like, it's just a line. It's just a line break. And other ones might include images too. So if I have an image I like, such as this image, and I get the URL of that image, or another image, this image here, sure. Why can't I get the URL? I don't use Edge for... What is that image? There's the image. Give me that URL. So here's my random avatar, I guess, on... Oh god. Oh god. I've ruined everything. Okay, let me just grab this one. So here's like my avatar on Slides. Is that a real website? I hope so. Yeah, so here's my avatar on the internet on slides.com. I can actually take that image, any URL on the internet, and I can actually dump that on my page with the image tag. Now the image tag is another void tag because there's nothing to put inside of it, and it has a property called source, and source is a URL. And what that will do is that will load up this on the page. Now, in this case, I'm pretty sure the server... Oh, I need to do... Yeah, there it is. There's the image. Nice and simple. I've included that on my page, and then the last kind of basic thing you can do is you can actually add a link in your page. So you can say... You can have an A tag, which is an anchor tag, which is a superset of being able to link things. And let's say, go to Google. Go to Google. Or I could say, go to Google right now. And you'll see that this is now going to be a link, but I haven't actually given it a URL to go to yet, and that's the hyperlink reference property. So I give it another URL and it tells you what to go to, and now the web page is ready to go, and I click on that and then I go to Google. Simple web pages. You don't need anything fancy. You could go and copy and paste this and load it up in your own web browser, and your web browser would do this because you already have a compiler on your computer. Now, this page looks like shit, right? How terrible does it look? It's awful. So that's HTML in a nutshell. It can do so much more than that. Everything I've just shown you, you've pretty much been able to do since the 90s, right? But there's a whole wave of changes that have come in that let you do crazy things like load videos and play audio and take photos with the camera. Like, browsers are extremely powerful with what they can do now. Trying to think of an easy example I could... Let's look at some HTML5 features quickly. Or is this just going to be... So HTML5 was a really exciting standard that So what happens is HTML5 is like a new standard of a language. And then people who build browsers go and actually make that work. So someone says, this is what HTML5 should be. And people who work on Chrome and Edge and Firefox and Safari all go, cool, okay, we'll update our compiler so that that can now happen. Examples of what were included were like audio and video tags. So you could actually load a video or play it on your website. Or audio, you could play that on your website as well. Vector graphics. The introduction of being able to like make little pretty pictures on your website, so I can like copy and paste this and it'll make a cute little circle for us on the page. I can change that circle to be a different color. Like, I want a blue circle. And I want a circle that's a little less, you know, big. Smaller circle, right? Header and footer, yeah, it's boring. Figures, you could add diagrams, navigations for Google to pick up on. Have you ever noticed you Google a website like, say, I don't know, Apple, and sometimes you'll see things like this here. Like, this isn't by mistake. Google actually like picks up on this because when Google looks at the web page, they'll actually see, I believe they'll have it, I'm guessing here. They can actually see here that like there's a nav section or something similar to that. I'm making that up a bit. But there's all these new features that were about making it clearer about what's happening on the internet. Placeholder attributes, yeah. Lots of stuff. And there's been even more since then. So that's all well and good. HTML exists on all web pages. It's the fundamental structure of a web page. It's how browsers interpret how to lay out the blocks on your web page. The problem is it's ugly as hell. So there was another language that came out shortly after called CSS, or Cascading Style Sheets, which had a focus on making that HTML pretty. So it wasn't interested in structuring a web page. It wasn't interested in any of that. It was just interested in making it look nice. And it was kind of like a way to wrap HTML or to like make it stand out. So if you think about it, it's like, think about HTML like, you know, like one of those, you know, at Woolworths, you get these like, meringue, how do you spell meringue? Meringue cakes? Meringue. Right, like if you've ever been to Woolworths or something similar, you'll see that there's like these like really boring cakes. Or I'm thinking of a different one. But you know, when you go to Woolworths and there's like the simple, maybe it's not meringues, maybe it's like a basic cake, and they just give you like this cake and they're like, here it is, it's just a baked cake. And you can just go home and like put more on it, right? This isn't going to go very well for me. I can feel it right now. But you'll be able to buy these, like, not the mud cakes, just like a double unfilled sponge cake. I think that's exactly what I was like hoping for. It's like a cake that's like literally just like a sponge cake cut in half, and they're like, here, go home and put stuff in it and color it and make it look pretty. But here's the cake, right? It's this tall, like it's this structure. HTML and CSS are somewhat similar, and there's be 100 other examples I could give you where, you know, HTML is really just giving you that foundation, and then you come in and actually, you know, make it look pretty and fill in the gaps so it feels like a complete item. CSS as a language is also very simple in that it basically is a short little bit of a markup language where you can specify certain things, and I'll give you an example. So typically on an HTML page, you can specify your CSS inside a style tag. So everything on a web page is HTML, but everything inside of a style tag is like a little kind of like a little virtual environment, if you will, whatever, that is actually just CSS. So inside of the style tag here, I can actually specify, think of this like specifying an object or something, like a template of sorts. I can say, you know what, I really want to have like, I want to have big text. And this is like a new style. That's why they call it style sheets, because I'm saying there's a new style I have called big text. And what I want is I want to apply a couple of properties to that, such as I want the color to be blue, and I want the font size to be twice the standard font size. That's what that means. Now this in itself doesn't change the page, because I actually have to go and... Where's my page? Did I lose my page? Because I actually have to go and apply this to something, where if I come along to any of my HTML tags, and I now say, you know what, hey, I'm going to give this a class of big text. Class is a way of essentially applying a CSS style to an HTML attribute, and now you can see that that CSS has been applied here like this. And you can do the same thing like this. I can go and take all of these header tags, and I could give them all this big text property, which will make them all twice as, well, it'll make them all the same size, not twice as big, but it will, it's a bit ugly, isn't it? You know, it can apply to multiple things. So if I add this a few times, you can apply this a few times, and then you can do other things like say, I want the font weight to be bold. To make it bold, you can say I want the font family to be Arial, because no one likes Times New Roman. You could say I want the letter spacing to be 150%, so there's like 50% extra letter spacing. Oh, maybe not letter spacing. 10 pixels? I don't know. There we go. 10 pixel letter spacing. Or you could do negative 10 pixel letter spacing. Let's get them all overlapping. Whoa, so modern. You make this, you know, make this look all dramatic, right? Doesn't that look a bit much? But you get the point, right? Like there's lots and lots you can play around with here. You can change the padding. Padding is the amount of space that is on either side of things. And what's really cool is that because your browser is a compiler, you can essentially actually analyze what's happening here. So if on any of your web pages you right click and you go to inspect, there's actually this little tool that pops up that actually shows you all the information about a given element. So you see I've got this thing here, this p tag, that's got, this is how big it is. This is the padding it has, this is the border it has, and this is the margin it has. So you can actually see it's got space on the top and the bottom. So if I want to override that, I could actually say here, I actually want it to have a margin top of say 10 pixels instead and a margin bottom of 10 pixels instead. And now they're all more bunched up. Or I could give it no margin on top and bottom. Make it quite compressed. Now every HTML element, well nearly every HTML element tends to follow a really basic structural model, which is that you have your element itself, which has a width and a height, or a width and a height, as I was about to say. It has a padding, which is the space between the element and the surrounding border. And then it has a margin, which is the space between the border and all of the other surrounding elements, right? So it follows that kind of tiered structure here. And I can give different, you'll actually see this. If I give it a border, say a border width of 1 pixel, right? And I give it a border color of black, border style of solid. I don't normally declare it like, there we go. So, you know, these are like 3 properties. It's like a solid black line. I could have like a dashed black line like that. I could have a dotted black line like this. You can actually start to see the relationship between padding, margin, and border, because if I gave it, say, a top and bottom margin of 5 pixels, there's more space between the border and what's around it. Whereas if I gave it, say, a padding top of 5 pixels and a padding bottom of 5 pixels, it's now space between the element and the border. So, you know, very different outcomes depending on what you're looking for here. And you can start to see, you know, if you stack enough of this up on itself, you eventually have, you know, a nice looking web page, right? So the thing is, like, we could talk about this for literal hours. So I'm like, there's lots of stuff I could chat about. I just don't think you got to draw the line somewhere. But that's kind of the crux of it. And if you want to make a new style, such as say red, you know, you could say I want it to be color red, and well, that'd be enough. And you could just go and apply this to all of your headers here. You could say my class is red. So class refers to this little name here, this dot name, and now all my headers are red. You can also style particular properties themselves. So the dot actually means class in this case. So when you say dot red, you're saying any HTML tag that has a class name of red. I can come along and I can say, I actually want to change what my H2 looks like. I want to give it font family Helvetica. Why didn't that work? Did I spell it wrong? Why doesn't that work? If I do Arial, does it work? No. What have I done wrong here? Let me just inspect this. It's being overwritten. Why is it being overwritten? Unknown property name. Oh, phony family. Oopsie. There you go. And now we have a different, you know, different font family for all the H2s we do. So if you do like a dot, it means like it's a class name. So anything that has a class of this will have that property. And if you just do an actual HTML tag itself, it'll just like apply that to any tags. You know, I love how I like solve my problem, and then I have to deal with the following, you know, minute of all of you having pointed out my problem before I found it with all the lag. It's still coming. So yeah, I mean that's CSS in a nutshell as well. I mean that's one of the good things about a lot of web stuff is it's relatively simple. You could teach a high school person to, well, not that that makes it sound like high school people are dumb. It's like, you know what I mean? Like you could teach like a year 7 student in high school to do all of this. It's very methodical. It's not programming, right? Like it's a language. You wouldn't call it a programming language. It's a markup language. You are just declaring what it should be, and it's just that. There's no if statements. There's no loops. There's some more complicated things you can do for sure, but largely speaking, it's a relatively contained environment. And then the last thing we have to chat about is JavaScript. Now, this is where things get a little bit more interesting. JavaScript is a programming language, and it's essentially the programming language of client-based web frontends, and I guess servers as well now. But JavaScript is a programming language that has an interpreter, just like Python does, and it's built into your web browser. The most popular one was built by Google, and JavaScript is what adds a dynamicness to your web pages, because everything we've done so far has been, here's some HTML, you declare it, it looks like it. Here's some CSS, you declare it, it looks like it. But how do we do more interesting things, such as conditional logic, loops, if statements, you know, all that stuff you're used to that actually brings a page to life. Now, like CSS, JavaScript is interpreted on the web page inside of a script tag. So CSS is in a style tag and JavaScript's in a script tag. Now, JavaScript as a language is somewhat similar to Python. I mean, it's depends what your benchmark is. It's substantially similar, more similar to Python than say HTML is or C, but it definitely still has some big differences. So in JavaScript, what did I just press? F9. What does F9 do? What in the world? Sorry, I'm just... Sort lines. Oh, there's a shortcut to sort lines. Damn. That would have been useful for the last 10 years. Not in this case. Wish I knew that. So, just sit up. I'm starting to get lazy and recline. Okay. So, how do we write some JavaScript? Well, you can do for loops just like, how would you do a for loop in Python, right? Or C. You'd say something like, you know, for int I is 0, I is less than 10, I plus plus. Then you'd say printf %d I. How would you do it in Python? For I in range 10. Print I. How would you do it in JavaScript? Well, in JavaScript you would say, well, in JavaScript there's no range, I don't think, but you would do something similar where you would say let I is 0, I is less than 10, I plus plus. I know I said it's like Python, but you know, most of it will be, it's not like Python, it's just a scripting language like Python. It's interpreted, it's high level, it's loosely typed and all of that. So what are some main differences you see here? Well, it has a very similar kind of core syntax to C with the parentheses and the braces and stuff, but you know, you're not really dealing with types. In JavaScript, there's only really two ways to declare a type. One is with the let keyword and one's with the const keyword. And let just means it's like a Python variable you can modify. So there's actually a sense of const variables in JavaScript, unlike Python. Like in JavaScript, you can say const a equals 5, and if someone tries to modify that, JavaScript actually throws an error. So this is JavaScript here, except you notice that instead of printing, I'm actually doing this thing called console.log. And this makes sense because if you think about Python, when you do print, what print's actually saying is print something to the console or the terminal you're working on. So the semantic is exactly the same here, it's just where it ends up. So you don't have a terminal on your web browser, do you? Because you're not compiling it like you are with Python. But if you go inside this, you know, this inspect thing on the side here, if you go to console, you can actually see the equivalent of a terminal here, and you can actually see I'm getting these outputs. So I can do things like, you know how in Python we have f strings, where we do something like this. In JavaScript, we don't have f strings, but we have something similar where in Python, if I wanted to say number is this, right? I would in JavaScript, it's slightly different. I'd say number is this. Different kind of syntax, but same gist, right? Backticks instead of that. And it's like, you know, now we're actually printing some stuff out to the console. So the thing is here is you can kind of just start applying the exact same logic that you would you know, in Python or C or whatever else, and just start programming things like, let's calculate all the squares of things, you know. Or even cooler, in JavaScript, there's a few things you can do, such as there's a prompt. There's a prompt command built into the browser. Is this what I want? Let's try it out. You can actually have this so you can say let count equals prompt. Please enter a number, like this. And when this runs on the web page, when the web page loads and it executes that line of code, I actually get this little pop-up here that says please enter a number. And when I press 5 and press enter, I can actually capture that, right? Let's actually capture that like this. 6. Okay, I just printed out 6 to the console, right? So, you know, and then suddenly it's like, well, if I have that, I can now do a for loop. I can now say, you know, for let I equals 0, I is less than count, I plus plus, and then I can actually console log all the squares, right? So I could say square of I is I times I. And there you go. Now I've written a dynamic program that actually prints out all the squares up to 56 squared. The reason I show you this first is because if you treat this language like it's a command line language like Python, all that's really different is the syntax, but a lot of the other things you know you can translate over pretty well. But the thing about JavaScript is that from its inception, it was designed to interact with HTML elements. And this is kind of where things get more interesting. It can also interact with CSS. So if you think about it, JavaScript is there to interact dynamically with HTML and to interact dynamically with CSS. Give you an example. Please enter a color. I'm going to take in a color. It's going to be a string. I'll call this color. And let's just console log it. Let's just console log that color. Color, red. Okay, prints out red on the terminal. That's good. However, what I want to do now is I want to update my h1's color to red. So what I can do with JavaScript, typically if you want to use any JavaScript to modify or read from HTML, you tend to give the tag you're interested in an ID. I'll call this main header. So now it just has an ID. This doesn't do anything to the page. Like, it stays like it is. However, I can use JavaScript to reference this now. So what I can actually do down here is now I can say document. Document is this global object that refers to my entire web page. So there's the whole document, and what I want to do is I want to get a particular HTML element by its ID, like this, right? And now I would like to set a CSS property, style.color, to be color that I passed in. So this line here is a bit heavy, but it's interesting. It's like, here's my entire web page. I would now like to actually get an element on that web page based on its ID. 2915. And then I would like to set its CSS property color to the color that was passed in. So now when I load this page and I type in blue, it now sets that to blue. If I refresh the page and I type in orange, it sets it to orange. If I do this black, it sets it to black. If I do white, it sets it to white. However, this isn't fun because we have to refresh the page all the time, right? So let's take it one step further. Let's actually put an input up here below the header, and it inputs another HTML tag. I'll give this an ID called like color toggle. And this input, by default in HTML, all inputs just take in text. So if I refresh this, you'll see it's just this text box here. And then I might put some text in front of it, like say color, like this. And then I'll put a button. I'll put a button after it called update. And there's the update button. So I've got this little page. I can type some stuff in here. I click this, nothing happens. They're all just structures, right? HTML structures. I haven't given it any CSS styles. This is just how the browser will default render it. I haven't customized that at all. However, what I would like to do is also give my button an ID, such as color toggle button. In fact, I might rename this one to color toggle input. Now, the reason I've wanted to give both of those an ID is because I want to be able to use JavaScript to detect when someone clicks on that button, and I want you to be able to use JavaScript to read from that input, and I want to use JavaScript to update the header. That's why I've got these IDs. So a lot of things that we want to work with, we need IDs. So now I'm going to go further down here. I'll probably get rid of a bunch of crap on this page, if that's okay, like this. In fact, I might just get rid of all of it. Right? And now I'm going to get rid of this prompt because I don't want it anymore. I don't want my for loop either. Like that. So now it's just a simple page. And what I'm going to do is I want to do a couple of things. I want to extract first the input value from this input box. So to do that, I can say const color equals document, like I was doing before, dot get element by ID on the color toggle input, because that's the ID of this particular HTML tag here, dot value. And this is just stuff I know because I work with it, but you'd probably Google it. It's like, what is that? Value is what's actually inside an input box here. Now, if I try and console log value or console log color, what's going to happen is that this won't work because when the page loads, this all executes immediately, right? Because this page literally just goes and just executes everything instantly. So therefore, even when I type in it, this line of code's already been executed. This is where things get to start to get into the complicated area of event-driven programming, because what I'd like to do separately to that is I'd like to say, you know what, on my document, I want to go get the color toggle button, that HTML element, and I would like to add what we call an event listener onto it, which is basically, it takes in two arguments. It says, for this particular HTML tag on your web page, I want you to listen for any clicks, and when a click happens, I want you to call a function. Now that function I'm going to come and define up here. We haven't talked about functions yet, but like, this is a simple function. It just, function name, think of it like Python, it's like def, that, it's all the same stuff. And when that function is called, there's a console log that happens, yay. So now in theory, if I've done this right, when someone clicks on my button that I've made, it'll be listening for a click, and when someone clicks on it, it'll execute that function for me. So now I click update, so it's executing my function. You can see that number's going up because it's being called a number of times. So this is actually working. But when I click that button, I don't want it to just print yay, I want it to print the input in that box, but thankfully I've already gotten this code here. So I'm just going to move this up here, and now whenever someone clicks my button, I'm going to go and read from this input value here, and I'm going to go red and click update, and it prints out red, and I'm like, cool, I'm going to change this to blue and click update, and it prints out blue. And then this is cool because I can do what I did before and say, you know what, go and get my main header and update its color style to be that color. And now I have a page where I can type in a color and update that. Orange, yellow, brown, like this. You know, cool enough. Purple. Aqua, is that a thing? Woo! Oh, is that did that just do blue? No, that did a light blue. Cool. Pink. So, I mean, this is it. And like, again, I'm kind of at the end of my road here on this topic, and you might be thinking, wow, that was really short and a bit compact. But the point of this thing is, again, like you could teach courses on this stuff for a year. Just like a whole year nearly. But it's all kind of just this at a bigger scale and with more intricacies and with more little special quirks to the technology and more capabilities you can do. But it's like you have a structure of a page, which is written in HTML in some way. You have the ability to style that page statically, which is written in CSS. And then you have JavaScript as a mechanism to add this dynamicness to it, to actually listen for events to occur, to call functions when they occur, and those functions are probably going to do something that actually updates the page itself. You know, for instance, maybe every single time, here's an example, let's get the current font size of my header, right? const font size equals, I'll go and get the header object here, and then I'll go dot style dot font size. See if this even works. I'm making this up. Okay, it doesn't seem to work. Font size, JavaScript, yep, font size. Yeah. I don't think this is what I want. How to change font size with JavaScript. Dot style dot font size equals that. Yeah, this. I think I know what's going on here. Let me just try something out quickly. Yeah, this is a bit of a complicated thing, but I wonder if I can get around it by changing the red here. Font size 20 pt. No. I think I have to do the get computed property thing. Oh, is that how you do it? I don't do this very much at all, so. Nope, that's not it. That's okay. I was trying to be too smart for my own good. So the reason this didn't work is it's to do with how some of this JavaScript stuff works. Sometimes there are properties that it only likes you, it only exposes to you if it's defined a certain way, which you can kind of gloss over what I just did because it's a bit of a hack to get this. Well, it's perfectly fine, but it's just how to get this particular example working. So it's like now when I click update, you can see I've got the actual font size of the H1. So what I could do is every single time say that I click that update button, I want to do a bigger font size, right? So I now want to say, well, okay, there's the font size currently. Let's set the new font size to be font size plus 5, right? So I want it to go up by 5 every time. What's the problem here? Nothing's updating. Why is nothing updating? Well, let's actually print out font size plus 5. Right, so I'm going to get the current font size, and then just before I update it to be the font size plus 5, I'm now going to print it out. And you can actually see what's happening here is that JavaScript sees font size as a string, because this is actually a string. It is then trying to add 5 to it, but the default JavaScript behavior of adding a string to an integer is to convert the integer to a string and add it together, right? Bit of a messy situation, not very great. So how are we going to get around that? Well, we could first turn our font size into a number. So I could maybe make a new variable called font size number. And that font size number, how would I do that? Well, I might Google JavaScript substring. You've probably maybe done something like this before. From a quick Google, I can see that if in a given string, I can actually say, get me the, here you go, here's an example, dot substring 13. So I know I can say font size dot substring 02, which I think should give me the right thing. Right, let's see what this one gives us. Okay, so I've extracted the 20, but now the problem is the 20 is still a string. I've just gotten a smaller string. So what I actually need to do here is wrap it in a parse int, which is like the equivalent of like a Python int cast. So now this should work. Now I'm getting 25. So now I can actually pass this into the property. And now every time someone goes to update the color, the font is just going to grow in size until it eventually gets unwieldy. Why did that get smaller? Oh, I know why, but that's okay. Purple. It's getting bigger. Right, so, you know, lots and lots and lots of things you can do. Anyway, that's the really basic introduction to it. I kind of want to wrap it up there because I feel like that's a very natural point, because again, I could just keep talking, but it's like you kind of need to spend an hour with it, and then the next milestone spending 5 hours with it, and then the next milestone spending 20 hours with it, kind of thing. This is a bit dramatic, but you get the point. So are there any questions about this? Otherwise, we can wrap up this topic. And, you know, yeah. I'll give you a sec just for the just for the lag to catch up. Cool. Well, I mean, if you do have other questions, I mean, there's only so much support we can give in this course. What the front end you're using for your project is built in is it's like a think of it like in Python, you have the ability in Python to use the networks library and other things to actually send HTTP requests, but Flask is this nice what we call framework that's wrapped on top of Python that uses Python in an easy to use way to get a result, which is a simple web server. There's tools we've written the project in that are very similar. The project's written in a JavaScript-like framework that simply makes things easier by, it's like designed for kind of these simple state-based web pages that you've seen. The leaderboard's also written in that kind of framework, and there's lots of them around. Max says, how does PHP compare to that? PHP was basically, the really quick history of it is that when the web came out, you had HTML and CSS and JavaScript. Really, really basic, though. And this was how you made client-side pages. How did you make server-side pages, though? Well, historically, I think some of the earliest server-side pages were written in Perl, a relatively, not that powerful language. In like the early 2000s, a language that really took over in interest was PHP, which stood for pre-hypertext processor. And it was I think the first language that was designed for web servers, fundamentally. Like, it was designed for web server-side code to render out client-side code and do other logic and stuff like that. Very ugly language. It's kind of like JavaScript, Python, PHP. They're all scripting languages. But this was the first one that was kind of web first at a big scale, where you could do a lot that you would want to do in, say, Python or something. Perl was really like a web-able language that kind of felt a little closer to Shell or Bash in a way. It just felt a little bit kind of more constrained. Not bad. PHP was a web-able language that was like maybe a little bit more like, Python and JavaScript. And then as Python picked up popularity, it became really popular. The only downside with Python is Python was never designed to be a web language. But it's a lot kind of cleaner language and an easier language to use. So that's where it picked up a lot of popularity. And then more recently, there's interesting things around. Most server sides are now built in JavaScript, which is by far the most popular one and where you would head to. That's why PHP kind of died, because it was really popular as the web was booming, and then there just became better solutions eventually. Rahul, if you have a project question, please ask. I'm going to wrap up. Like, if you have questions, ask in the next 1 minute. Otherwise, we'll wrap up. I have a question for you. Not right now, but just before we wrap up, I'll re-record. But I have a Teamwork Thursday question, which isn't so much. It's a little bit of a story, but it's mainly things I want you to ponder over. Rahul asked a good question. Why are Reacts a list of dictionaries when we only use the first element? I'm not sure what you mean by a list of well. Let me look up the data structure really quick. I think I have an answer, but I don't want to get it wrong. The original intention with Reacts was that we would expect students to go and add their own Reacts to it. But we just never pushed that too hard, because list of dictionaries where each dictionary contains React ID. Yeah, so basically it's because there's only one React. Like, we were originally intending for it to be a thing where we could add many Reacts, and you could have like a smiley face or a grumpy face or something similar. Yeah. Cool. Well, that's about it. Cool. Thank you. Please leave some feedback on that. It'll be good to know how people enjoyed that, or if they didn't enjoy it, or etc. Because it's all useful feedback going forward. So, thank you. Do the QR code.